Okay, so we're going to start to talk about conversions. Okay, so you know, the stuff about doing molar masses from compound names is pretty easy. It's just building on a skill you've already got. The challenge on those practice problems, of course, and this is where I keep talking about the chemistry ladder. You're building skills that you're then going to stand on. Being able to write correct formulas enables you to then find correct molar masses. If you write the wrong formula, then you find the wrong molar mass. So you're building steps in a ladder and you're now standing on them. So we can find the number of moles, and this is more what's called composition stoichiometry. Composition stoichiometry, which I just love to say. Stoichiometry, composition stoichiometry. Because we're still just looking at the stoichiometry of individual compounds. We're not yet looking at the stoichiometry of two different compounds reacting with one another. So we go back to our old GMA, our old standby. And when we were initially doing conversions, we said, G was for grams. Here, that's for molecules or formula units. So here it becomes that. M is still for moles. Oh gosh, no. Duh. Wrong. Atoms becomes molecules or formula units. I'm sorry. G is still for grams. So we still have grams and moles, but instead of atoms, now we're dealing with either molecules or with formula units. So it's only a subtle mental shift. Okay, so we'll do a little bit of practice on this. How many moles are there in 100 grams of sodium chloride? So, just like you did with composition stoichiometry, where you were looking at moles of carbon or moles of sodium, we're going to start off in the first box, always with our, it's been a while, our given. So we have 100.0 grams of sodium chloride. I cannot stress enough to you the importance of putting the chemical in there, because right now we're dealing with problems where you're all in the same chemical. Pretty soon, very soon actually, you're going to be in problems where you have multiple different chemicals in a factor label. So it's going to be really important that you put in not only units but chemical. Okay, so we have 100 grams of sodium chloride. What do we want to know? We want to know how many moles there are. So we know in any factor label what's going to go, units in chemical, what's going to go down here. We're going to put in grams of sodium chloride because we have to have the same units in chemical over and down to cancel. And we want to end up in moles of sodium chloride. Can we go straight from grams to moles? Yes. We don't have to go through molecules or formula units. So we know that this will be moles of NaCl. And now we're looking to put numbers in there. So what number always goes with 1 in any conversion? Well, there we go. What number always goes with moles in any conversion, unless it's your given? 1. I gave it away. And where are we going to get the number that goes down here that illustrates the relationship between grams and moles? It's going to be our molar mass. So I'm going to do my little quickie here. Sodium is, who's got the molar mass for sodium? So, where do we get that relationship between grams and moles of NaCl? Molar mass. So, sodium, who's got it? 22.99, and this would be grams. And a note here, I'm by standard rounding to 2 decimal places. I'm using 2 decimal places everywhere. You're always welcome to use more. You can't use less. I know in physical science, some people in physical science say, round to the nearest whole number. We're a little bit pickier about that because now you're stepping up the chemistry. So it's a little bit more serious. Okay, chlorine, what do we have? 35.45 grams. Okay, so for the molar mass of sodium chloride, so we have 58.44 grams of sodium chloride in 1 mole of sodium chloride. So we divide our 100 by 58.44. What do we get? So I've got an initial raw answer of 1.7111567. It just keeps going on and on and on. How many sig figs do we have? Where do you get your sig figs from? You're given. So we have to look back to our given, and we see that we have 4 sig figs in our given. So 1, 2, 3, 4. This is going to have 4 sig figs in our final answer, so 1.711 moles of sodium chloride is what we're dealing with. Okay, if we want to know how many molecules there are in 250 grams of C6H12O6, that's glucose, let's set that up. What goes in our first box? As always, the given. And we had 250.0 grams C6H12O6. We want to end up with a number of molecules. So, can we go straight from grams to molecules? No, we have to go through the mole, the mighty, mighty mole. So, what units, what chemical in the next box and below to cancel? Grams C6H12O6. And, of course, we'll have moles of the same up top. So, in that last box, what units, what chemical on the bottom? Units and chemicals have to cancel. What are we going to end up with on the top? We're going to end up with molecules. Be careful when you're using molecules, because if you get sloppy and you just write MOL for molecules, you're liable to confuse yourself and think that you've got moles there. So I know some of you find it torturous to write an entire word out, but for here I would really suggest that you do that. So moles and molecules are a big difference. Okay, middle box, where do we get the numbers for moles and grams? What always goes with moles? 1. And where are we going to get the number for grams? Molar mass. So I'm going to do my little side calculation over here. C, H, and O. C is 12.01. That's one of the ones that you're going to have memorized in no time. Times 6. Hydrogen, 1.01. Times 12. And oxygen, 16.00. Also times 6. Let's get this out of the way. What do we get? Okay, so we've got 1 mole of glucose, C6H12O6, contains 180.18 grams of C6H12O6. Now for that last box, we've got our units and chemicals set up. Where do we get the numbers? So what always goes with moles unless it's your given? 1. And there is one number and only one number that can go in front of the word atoms or molecules unless it's your given. And what is that? 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd. This is where I find it personally easier when I've got anything that has scientific notation to make everything scientific notation. because my little pea brain can't handle moving decimals. So this is where I tend to do this, and I say, well, this is 2.50012 times 10 to the second, and this is, let me move that down, this is 1.8018 times 10 to the second, and of course you can see your 10 to the seconds are going to cancel out there. But that makes it easier for me, because I tend to really screw up horribly if I try to move numbers around. Okay, I'll set that down to the side. Okay, so calculators. Okay, so as my raw answer, I get 8.3555, etc., 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 times 10 to the 2 minus 2 plus 23. You know, pulling those out of here. So obviously our 2's cancel, so what do we have for a final answer, and how many sig figs are we allowed to have? We can have 4 sig figs. So we get 4, 8.356 times 10 to the 23rd. Oops, what did I forget? Molecules of C6H12O6. That would be my final answer. Okay, let's do one more together. So for our last one, we've got what's the mass in grams of 8.0 times 10 to the 45th molecules of CH4OH. That's an impossible compound. I apologize. That should be a 3. I will need to go back and edit my notes. That should be CH3OH. You don't know why that's an impossible compound, but I do, so it sticks out to me. Okay, so 8.0 times 10 to the 45th molecules of CH3OH was in our first box. Given, which was 8.0 times 10 to the 45th molecules, and we are going with my corrected formula since I screwed that up. CH3OH. That's actually methanol. Okay, what units, what chemical? Next and down to cancel. Units in chemical? What is it? Molecules of methanol. Okay, and we want to go to what? Grams of methanol. So, can we go straight from molecules to grams? Remember that this is atoms or molecules. Can we go straight from that to grams? No. We have to go through moles. So what's going to go in the top and our middle box on this one? Moles of CH3OH, methanol. Okay, and what's going to go in our last box? What's down on the bottom to cancel? Moles of methanol, moles of CH3OH. And what's going on the top? Grams of the same thing, CH3OH. Okay, so the relationship in that middle, what number always goes before moles unless it's your given? 1. What number goes in front of molecules or atoms unless it's your given? 6.022 times 10 to the 23rd. 6.022 times 10 to to the 23rd. And again, what number goes in front of moles? 1. Where do we get the number that goes in front of grams? Aha, to the periodic table. So we have carbon, hydrogen, and oxygen. 12.01 times 1. Hydrogen, 1.01 times how many? Be careful. You want to say 3 because you see that subscript. Count your H's. 4. You've got 3 here, and then you have a 4th hydrogen there. So 1.01 times 10 to the 4th, how many oxygen? 16.00 times 1. What's our mass for methanol? So we have a molar mass for methanol of 32.05 grams per mole. Okay. Again, this is my preference. Anytime I've got scientific notation, I tend to try to make it all or nothing, so this would become 3.205 times 10 to the 1st. And that's, again, just my little weird preference. I find it easier that way, to have it all in scientific notation or none of it. Okay, so for my initial raw answer, I've got 4.25771. It goes on and on and on, times 10 to the 45 minus 23 plus 1. How many sig figs can I have? Just 2, because my given only had 2. So I have 4.3 times 10 to the what? What do you have? 10 to the 23rd. So we have 4.3 times 10 to the 23rd grams of methanol CH3OH. I'm going to say this is a ridiculous problem because that's so many grams of methanol that you would, need a building the size of this to store it all. It's a ridiculous quantity. So whoever wrote that problem, me, should be summarily, pelted with alum tablets. Yeah. Anyway, that's the basics. You're doing the same thing that you did back in Chapter 3 when you were starting to play with stoichiometry. I'll give you some more practice problems. You can work on the practice problems on your sheet. I'll give you some homework problems, and the ones that you have on that practice sheet, you'll just turn in with your homework and we'll grade them with the homework. So that's it.